So we got that going. Welcome. My name is Ryan Holger, Temperature Equipment Corporation. Our subject matter today is indoor air quality. We're going to look at this from both a residential and commercial perspective, a commercial building perspective, residential homes. Obviously, the things that pollute the air are usually the same things. How we handle it may or may not be different just because of the size of the HVAC systems may matter. But there's so much overlap, we can talk about both things simultaneously. Obviously, there's lots of things in the news regarding influenza, influenza B, coronavirus, all this other stuff. So we're getting like a million different questions about indoor air quality related things. So we thought it'd be a good idea to go through all the fundamentals with everybody, all the solutions with everybody, talk about what stuff can and can't be killed by different solutions, and kind of look at it from that perspective. If you guys have questions, please type them in the chat box as we're going. I'll try to glance over there once in a while and read a few of them out. There's like 200 people on this one, so it might be a little bit difficult to do everybody's question. So if I don't get your question, I apologize. You'll have to send me a note later, and I'll follow up with you after the fact. With that, let's dive in. So here's our general lineup for what we're going to talk about. We'll talk about the pollutants that are in the air that affect our air quality. Talk about how we filter them, what standards there are, what kind of filtration there is, how filters are evaluated. Talk about air purifiers and various air purifying technologies. Talk about UV lights and so on, etc. So the things that are actually in our air that are causing the problem. Typically, we can dump these into three categories: particulates, microbials, and gases. So what do those things mean? Microbials are basically stuff floating in the air, chunks of stuff that's relatively big, at least big as compared to microbials. The particulates, for the most part, categorized into three things as well: dust, dander, and pollen. And the way I typically look at it from my perspective is dust, which is mostly made out of human skin cells. If you didn't know that, it's kind of disgusting, but that's what a good portion of dust is. So dust is basically stuff coming off of people. Dander is the stuff coming off of your pets and animals, and pollen is the stuff coming off of the plants. Various people have various allergies and reactions to these things. Some people don't, they're not bothered by any of them other than the visual dust. Other people are allergic to various things, especially like dander, right? So if you got allergic to cats, all of a sudden getting rid of dander from cats or dogs or whatever it is a bigger deal in your life than someone else. And there are a lot of people that are allergic to pollen. Those people are usually smart enough to not to have plants inside their building or house. But when the season changes and pollen gets sucked into the air intakes, it does make a difference for people. So the particulates are physical, larger pieces of debris, typically dead debris coming off of previously living things. On average, every person in the country inhales about 2 tablespoons of particulate matter each day. That has no bearing on our discussion today. It's just disgusting, so I figured I'd point it out. But that is quite a bit of stuff. If we don't do something with the mechanical system in your building or in your house to filter that, then your lungs become the filtering mechanism for that. They do a good job of that, but I'd rather not have that stuff built up in my lungs if I can avoid it. The second category stuff is microbials. Microbials are living organisms. These can be bad for you or they can be good things. Just depends on what they are and where they fit into our lives. The microbial stuff typically falls into 3 buckets as well: bacteria, viruses, and mold spores. Bacteria, there's good and bad bacteria. You probably have heard that before. You have bacteria in your stomach that is used to help break food down, right? We're not talking about that kind of bacteria. We're talking about the bad bacteria. Although all the solutions that we're going to talk about that kill bacteria will just kill bacteria equally. They're not discriminate. But some of the things that we definitely want to get rid of inside our buildings: E. coli, staph infections like at hospitals, MRSA at hospitals, strep throat with your kids at home, that kind of thing. We want to attack all of that kind of bacteria and eliminate it from our indoor environment. The second category is viruses. I believe there's only bad viruses. I've never heard anyone mention a good virus. Right? All viruses seem to be bad. Influenza obviously is very common, the flu, cold, the Norwalk virus or norovirus, depending on how you hear it referred to, avian bird flu, SARS, H1N1, the new coronavirus. Obviously, all of these types of things that we hear about are not good for you. Most of us are concerned about the flu and the cold because that's what goes around every single year all the time. But sometimes things happen in the world where we want to pay attention to some of these more rare viruses as well. The third category stuff is fungus. Obviously, mold is a fungus. There are good and bad funguses, right? Like, so you eat mushrooms, eat blue cheese. Penicillin is mold, basically. So there are ones that are good for you. There's also ones that are very bad for you, that could have adverse effects on your health and on your breathing. So we'd rather not have mold growing inside someone's building, if we can avoid it. Or even if we can't avoid it, we still don't want it to grow there. This is a picture of my house where I grew up. It's why I'm so short and small. I was not able to fully grow and develop because of all the mold I had to breathe in. Obviously, I'm kidding. This is just the grossest picture that I could find on Google of mold in a building. This is somebody's house. And if you look at it visually, obviously the ceiling is trashed. And that back wall, you can also see mold on that, even though we're pretty far away in the picture. But you can kind of see it. It's funneling down towards that door jamb. It indicates to me that the mold is flowing, if you will. It's got a pattern to it. It's on part of the wall, but not on other parts of the wall. That probably means this mold situation is caused by a water leak above that ceiling. Probably a leaky roof. Could be leaky pipes, but probably a leaky roof. So sometimes mold is caused by the environment. Sometimes it's caused by the HVAC, or rather, it's not well prevented by the HVAC. So in order to figure out what the problem is, obviously you guys on this phone call are all HVAC folks. So if the mold is being caused by a leaky roof, that's not your problem. You may get blamed for it, but it's not your problem. So we got to be able to determine what it is. In order to grow mold, I need at least 3 things at a minimum. So I have to have the mold spores in the air. That's not a problem because there's millions of them sitting in the room with me right now. They're just everywhere. So that's pretty readily available. I have to have some kind of food source for the mold to grow on, and pretty much it's anything organic at all. So, the proverbial mold on an orange for penicillin, moldy bread, drywall, wood, particulate board, debris and dirt stuck in your carpet, like just about anything that's living or was living can become the food source for the mold. So that's pretty easy to find. The third thing is moisture. Mold will thrive with more moisture. So of those 3 things, moisture is the easiest one for me to control. If I can get rid of the moisture, I'm going to be in good position here. So in order to get rid of the moisture, I have to eliminate the source of the moisture. If the source of the moisture is a leaky roof or leaky pipes, okay, I got to find the leak, make the leak go away, right? Seal the pipes up, redo the roof, whatever it's going to be. But sometimes the moisture comes out of the air. That's when it becomes an HVAC problem. Or I guess it could be an HVAC problem if the leaky pipe is the water line to your humidifier or something like that, or your chilled water line. But the moisture in the air becomes a problem. Typically, high humidity inside buildings can be easily prevented by properly sized air conditioning equipment. As most of you know, especially if you've come to any class I've ever done on any subject, I probably bitched about oversized HVAC. It is probably the #1 cause of high humidity in spaces. Nearly 100% of HVAC systems are oversized, and my estimate would be about 50% are what I'm going to call grossly oversized. So getting those load calcs right, getting the smaller system in there is going to help. The smaller the system is, now once again, not too small to do the job, but the smaller the system is, the longer it's going to run and the more dehumidification I'm going to have. When your air conditioning unit first kicks on, it starts making the evaporator coil cooler. After 3, 4, 5, 6 minutes, the evaporator coil gets cool enough to reach the dew point, and then I start dehumidifying. But if my system is oversized, I turn off the cooling system quickly, which means the coil never got to the dew point, and I don't dehumidify much. If you need more help with talking about oversized systems, see me. I'd love to talk about it for hours and hours on end. But today we only have an hour, so I got to keep moving. The third category of things is various types of gases. All kinds of pollutants can be gas related. Carbon monoxide, obviously one we think about all the time, cigarette smoke, things like that. The 2 that we're going to focus on for right now are VOCs, volatile organic compounds. These are typically chemicals that are involved in most of the things we use in our buildings. So VOCs are in most paints, sealants, press boards, furniture, all kinds of stuff like that. They dilute themselves over time, so as the carpet and furniture and wall paint gets older, it gets diluted down. But in newer buildings, the VOCs are pretty high. When you buy a brand new car and you get that new car smell, yep, that's VOCs. Some people can be affected by this. Nauseation and irritation and scratchy eyes and stuff like that are some of the common symptoms. So we want to do things to eliminate VOCs, which means don't put high VOC products in your building. And if you do, let's find some things that eliminate and neutralize VOCs. Odors are things that are generally not harmful to people. They are just annoying. So if the person next cubicle has nasty cologne and perfume, or even if it's wonderful cologne and perfume, you just hate it, or reminds you of your ex, great. Or not great. But we need to get rid of those odors so people don't have to smell people. Body odor, sweaty smells in a gym, locker rooms. We've had projects where there's been apartments where the person in one apartment cooks some weird ethnic food that the person in the next apartment doesn't like the smell of. So eliminating odors can be something we have to focus on too from an indoor air quality standpoint. Let me define a couple terms here. I don't like either one of these two terms that I'm going to define, but people use them, so I'm going to have to define them because people are going to ask. You guys are going to type questions in. One of them is sick building syndrome. So basically, this is the phenomena where people go into a building, probably their place of employment, and after they're there a couple hours, they start feeling nauseated and dizzy and all that kinds of stuff. Something is causing that problem in the building. Now, this is not just one person. This would be lots or most of the people in the building having this type of symptom. Then they leave and go home and everything is fine. Right? They go back to work the next day and they feel like crap again. Most of us just call that Monday, but for some people that persists throughout the entire week. So obviously, we'd like to find the cause of the pollutant, eliminate it, make it go away, and then everybody's happy. When the people can't find the cause, they label the building as quote unquote sick building. That's why I don't like this term, is because it means you didn't figure out what was wrong and you're just saying it's sick. It'd be like if you went to the doctor and the doctor said, "Damn, Ryan, you are sick. You are going to die." And you're like, "Oh my gosh, what's wrong with me?" Doctor's like, "Dude, I have no idea, but it's really bad. I have no clue." You're screwed, right? If you can't tell me what it is, how the hell am I going to fix it? So that's why in these kinds of applications, when someone has a sick building, we'd like to identify what the problem is. There are experts that can help us do that if it's beyond our skill set. There's a dude up in Wisconsin that's a microbiologist that specializes in buildings, kind of an interesting little niche. We brought him down for projects before to help us out. So if you need something like that, let us know. Dirty sock syndrome, same exact kind of thing, except it's not people getting sick. It's just a general disgusting odor, typically a mildew or moldy type odor. Locker rooms have this all the time, kind of thing. Same kind of thing. You're telling me that it smells. You're telling me it's gross. You're not telling me where the source of the problem is, so I can make it go away. So we'd like to define that, find where the bad odor is coming from, and make it go away. Probably from underneath your kid's bed. Most buildings, residential and commercial, have tons of IAQ problems. Residentially, I forget the exact statistic, but it's something like 80% of homes have like 2 IAQ problems or more. These ones here are the most common ones. As an industry, meaning the HVAC industry, we do a pretty good job of making sure we don't have carbon monoxide coming from our boilers and furnaces and things like that. Because obviously if we did, people would die and that wouldn't really work. Right? There are some buildings out there that have low levels of carbon monoxide that we, the industry, have not found, and we need to help the people with that. But for the most part, we do a good job of that. And for the most part, we do a good job of temperature control, because that is, in fact, what our industry is. Although 21% of the people say their temperature control sucks, so that's still not awesome, but we do a decent job. Humidity, we need a lot of help on that. We have a lot of buildings that have too low of humidity in the winter, too high of humidity in the summer, and we as an industry do a poor job. Once again, reference the oversized air conditioner example I had before. Carbon dioxide is not a pollutant. If you need more information on carbon dioxide, let me know. We just did a webinar for that on People's Gas a couple weeks ago. We have other recorded webinars we can help you with on that exact subject. But carbon dioxide is a measurement, it's a way to have a surrogate measurement for the amount of people in the space. It's not a pollutant in itself. It comes out of your mouth. You're the one creating the carbon dioxide. VOCs we just talked about, and particulates we just talked about. And there's lots of buildings that have those specific issues. Those are pretty rampant. If anybody has any questions, type them in the chat box. I don't think I've missed any so far, which is not abnormal because we're at the beginning of the discussion. But as we go on, you'll probably have some questions. So type them in, and I'll try to reference them every 15 minutes. I'm going to look and see if there's anything exciting. So only send me exciting questions, no boring stuff, man. All right, so that kind of gives us a primer on some of these pollutants that we're trying to deal with. Now let's talk about some various solutions to get rid of the pollutants, both residential solutions and commercial building solutions. So we'll start off with some of the normal things. First off, we got to figure out what the hell we're trying to get rid of. And we're going to begin our discussion with filtration. So to filter stuff, I need to know how big it is, essentially. We measure really, really small stuff in a unit of measurement called microns. You can see across the chart there, 0.0001 microns up, to 100 plus microns. And then in the green section there, you see the various air pollutants and what size range they fall into. So up on the larger side of the scale, we got things like hair, sand, pollen, stuff like that. Down on the really small end, we have viruses and gases and stuff like that. We'll come back to this chart multiple times throughout our discussion today as a reference. So some of the stuff we're talking about is really, really tiny. This item you see here is a human hair, which is basically like 80 microns wide. And some of the stuff we're trying to find is just like a dot on the side of human hair. So it's going to be really difficult for us to get rid of some of the stuff with filtration alone. We might be able to do it depending on the kind of filters, and we'll talk about that, but it's going to be challenging. We have 3 types of filters we use in the industry: mechanical, electrical, and chemical filters. We're going to shelve the chemical filter discussion. That's typically industrial type processes. We're going to focus more on mechanical and electronic filters for our discussion today. Electronic filters are available both residentially and commercially. They were really popular in the 80s and 90s. They have since fallen out of favor by a lot. Like, I don't know anybody who still buys one kind of thing. You can still get them. Most of our manufacturers stopped making them. I think we still have 2 suppliers that offer them here at TEC. But a lot of them stopped making it because the volume was dropped. The reason the volume is dropped is because even though electronic air filters do a good job at catching stuff, and they have a very low pressure drop associated with them, which is very beneficial, as we'll talk about in a minute, the problem with electronic air filters is they have to be cleaned. And people, generally speaking, are lazy and they don't want to clean them. So whereas a media filter, you slide it out, put a new one in, throw the old one away. It's typically the American way, right? Just make everything disposable. It's the same reason you all bought coffee in a disposable cup instead of using a mug today. But if you enjoy cleaning dirty filters, then you can still get an electronic air cleaner, and then every few weeks or so, you got to clean it. Because once those plates get full of dirt, by the way, the electronic air cleaner, it's charging the particles that come into the air one way, let's say, for example, positive, and then it's charging the plates on the other side negatively. Positive, negatives attract, so your piece of debris is clinging onto the plates. But then you got to take those plates out and clean them so that way they can be used again. Once the plates have stuff attached to them, they don't do a good job of catching more stuff. So electronic air cleaner is only good for the first X amount of weeks, and then it's kind of full, and then you got to clean it. So we're not going to spend much time on electronic air cleaners, although some of the air cleaners we're going to talk about have electrical power sources. We're not going to focus on electrostatic air cleaners like we're talking about here. We are going to talk about mechanical filters. So mechanical filters basically impede the progress of the debris. There are 4 ways that the mechanical filter will do that. We'll talk about each one of these. Not that I would expect you to explain that to your building owner or to your homeowner, but just so you understand how it works. The first one is impingement. This one's pretty straightforward. That blue circle on there is one of the fibers in my filter, whether it's a plastic fiber-based filter, whether it's a fiberglass filter, whatever it happens to be made out of, that is one of the fibers there. I have a piece of debris coming along the airstream. In this case, it is dust. He slams directly into the piece of fiber. He gets impinged on the fiber. He ran into the brick wall. That's it. He's done. He's stuck there. All right, that one's pretty straightforward. Interception, that piece of debris, dust in this case, did not directly slam into the brick wall. He kind of like ground himself along the guardrail on the on-ramp, and the friction between the fiber and the piece of debris, the dust, made him stop there. Just like if you ground your car along the guardrail, your car would stop as well. That would be interception. Straining, that one's the most obvious one that we think of. All right, so if you took a pot of boiling pasta, poured it through the strainer, the water is small, it fits through the holes. The pasta is big, it doesn't fit through the holes. Same thing happens here. Air, which is smaller than dust in this case, fits through the gap. The dust does not fit through the gap, he gets stuck there. This does a really good job, obviously, of catching all the dust. The negative to this is that as I fill in those little gaps and holes with my debris and dust, then I'm no longer able to move air through there. So as the filter gets loaded, it does a worse job at moving air. It has a higher pressure drop associated with it, which for a constant volume system means I move less air. For a variable volume system, like a VAV air handler or like a variable speed residential furnace, one of those kind of products. In those cases, he's going to have to ramp up to move the air that he wants through the holes that are left, which means he'll use more electrical energy. Let's see, we did get a question here. Let me expand it real quick so I can read it, if I can figure out how to do that. Howard asks, did electrostatic air cleaners fall out of favor because of laziness? Is ozone smell an issue? I've not heard of anybody complaining about ozone smell from electronic air cleaners. Everyone that I have talked to, including residential contractors, for example, have stopped using electronic air cleaners because their customers complain they don't want to clean them anymore. There could be a slight ozone smell. I've not smelt that. But I personally like ozone smell. It's the same smell you smell on a rainy day, and I like that. So if I smelt it, I probably wouldn't be complaining about it either. But other people might. The fourth mechanism to catch a piece of debris is diffusion. Diffusion is the hard one to explain, and I always think about deleting it out of my slides and just pretending it doesn't exist, but it comes into play later when we talk about certain kinds of air purifiers, so I need to explain it now. And you notice I changed my piece of debris from dust to germ. Germ is a technical term, right? So it means a really, really, really tiny thing like a virus or something like that, something way smaller than dust. So some things are big, like dust, and hence they have some mass associated with them. When you have two items with mass, they are physically attracted to each other, just like your body has mass, and the earth obviously has mass. So we have that gravitational force that pulls your body and the earth towards each other. Now the earth is so big that it doesn't really move. Your body just moves closer to the ground. If you don't believe me, climb up on the ladder and jump off, and you'll figure it out, right? So other smaller objects have that same kind of thing as well. It's just that you don't notice it because the earth is so massive, the gravitational force is pulling him down with more force than the two little things are pulling towards each other. However, when something gets really, really small, it doesn't care about gravity anymore. Gravity is not really its problem. This little germ in this case has so little mass, he doesn't care about gravity. He's just going to float about in the air doing whatever he wants because gravity doesn't affect him. He also is so small that he doesn't really care about airflow either, right? So if something has some surface area to it, then airflow, breeze, wind, HVAC, air handler, whatever, can push against that surface area and move that thing along, like it could with a piece of dust. These little viruses and bacteria and germs are so small, they don't have enough surface area for airflow to really matter either. So they don't care about airflow, they don't care about gravity. They just basically float around in the air doing whatever the hell they want, whenever the hell they want. They're very difficult to catch with a filter because a filter requires the airflow to bring the germ to the filter. And since they don't get stuck in the airflow, no big deal. So on our drawing here, we show him as a little squiggly line because he's ignoring the airflow. However, if that guy does happen to come into contact with the fiber, the attraction of the mass of the fiber and the mass of the germ, because they're so close to each other, they will in fact attach to each other. But he's basically got to touch it for that to happen. We will come back to this principle again later on in our discussion today. Bob asks, just curious, is radon gas relevant to this conversation? Radon gas develops inside the dirt, inside the earth, and then in some applications, especially residential homes that have dirt or gravel crawl spaces, permeable crawl spaces, allow that radon to seep up. The radon coming out of the ground is not that big of a deal in of itself. When it seeps up into your house is contained, and then the radon builds up, and then that's when you would in fact have a problem. Coming out of your yard, no big deal. It dilutes down with the air. Coming into your house, it fills your house. So it does in fact become a problem. None of the solutions that we're going to speak about today are going to be related to radon specifically, other than general ventilation, which helps out with all pollutants because of the dilution properties. So when we're selecting a mechanical filter, there are some things that come into play. How good is the filter? Sometimes referred to as the efficiency. How quote unquote bad is the pressure drop? I don't want to have a filter that has 0.5 inches of static pressure drop on a system that can only do 1 inch to begin with. And how much airflow can I move through this bad boy? ASHRAE over time has had 2 tests for testing filters. If you are a mechanical engineer and you still put ASHRAE 52.1 in your specs, or if your spec refers to percent at all, you are on a standard that is so old, it was before I started in the industry when I started in 97. You need to get rid of that. It is long gone. We are now using ASHRAE standard 52.2, That's been around since 1999, and it gets updated regularly. But ASHRAE 52.1 is long gone, so we're going to ignore that. Delete it from your specs. Update all your specs. If you need help, let us know. ASHRAE 52.2 is the one that established the MERV rating system, which is what many people refer to their filter effectiveness as. So the way that basically works, when you have your filter tested, not that you would have your filter tested, but the filter manufacturers do this. They run the air through a really good HEPA filter. Then they inject a known amount of particles in there with a particle generator. Then they have a particle counter count to see how many they injected. They run it through your filter that you want tested. Then they count the particles again. Well, we injected X amount. We now have Y amount. How many particles did we catch? And they do that for different size particles. And then if you can catch smaller and smaller particles in larger and larger quantities of them, you will get a better MERV rating. That's kind of like the 60-second version of how it works. The MERV rating scale goes from 1 to 20. If you're buying filters that are below 6, it's worthless. I wouldn't even bother doing it. It's basically like putting a t-shirt in the air handler. It's useless. It's a cheesecloth. Most of the time, you're going to want filters that are at least a MERV 6 for really, really low-end applications. And then as you move up the scale, you'll get requests for 8 or MERV 10, 12, MERV 18, MERV 20. When we do hospital-type projects, which we do a lot with our air handlers, you're going to have HEPA filters on those. And if you put that on the MERV rating scale, it's going to be typically like a MERV 18 or 19. So there's different categories of stuff in that regard. But we can get various kinds of MERV rated filters in various kinds of installation applications, cartridges, bag filters, HEPA filters, and we'll talk about how some of these guys get installed physically in the system. And even residentially, we can get up to like MERV 15 or so. There may even be a MERV 16 one out there. So what does that physically mean? Well, if I look at the size of stuff, let's say I had a MERV 10 filter, for example, or even a MERV 12, I'm catching stuff in the 1 to 3 micron category. So 1 to 3 on the chart over here means I'm getting hair, I'm probably getting mold, some bacteria, sand, pollen, stuff like that. But I'm not doing anything for most things, like I'm not getting any odors, gases, viruses, nothing like that. Probably only getting half of the dust that I could be catching. I go to something bigger, like if you guys are doing residential work, you get up to like, say, a MERV 15, I can get down to like 0.1 microns. 0.1 gets me down a little bit more. I'm getting pretty much all the bacteria at that point, most of the dust, etc. The pressure drop of the filter is also important. Preferably, people would measure the pressure drop of their filter and change the filter when it's actually dirty. Hardly anybody does that, so they just change it based on some random time or something like that. Both residentially and commercially, we have systems that can automatically track the pressure drop of the filter and then alarm the user. So for example, residentially on Infinity systems, Carrier Infinity, Bryant Evolution, the top end high-end day and night furnaces and fan coils, they have the ability to automatically track the static pressure, and as static pressure changes over time, it'll give you the alarm that there's a dirty filter. Then commercially, we do the same thing through building automation systems. We put a pressure switch across the filter in those cases and use that pressure switch or a pressure transducer, one or the other, to alarm the building maintenance folks that the filter is in fact dirty and needs to be changed. Fun fact, the dirtier the filter is, the better the filter actually is. It'll catch more stuff. The more debris on the face of the filter, the more new debris gets caught rather quickly on there. But obviously the negative of that is that I can't move air through the filter very well, and or it costs me more electrical energy to do that. So either way, that part is bad. So you're trying to get that sweet combo of when I need to change my filter because it's dirty and the pressure drop's starting to build up kind of deal. Lots of ways you can also measure pressure drop in the field. This audience shouldn't have to be told what a manometer is. If you don't know what that is, come see me. We'll get the help figured out for you. All right, so one of the other things with filters before we switch over to air purification here is I want the air to go through the filter slowly. If the air goes through the filter quickly, it'll have more velocity pressure, and hence it'll be able to push the air through the filter more easily. So I want it to go through slowly. One way to make air move slower is to make the air handler and or the ducts bigger, right? So if you can imagine, let's say I just had a really small duct, like an 8-inch round. It's coming through with a certain amount of CFM at a certain velocity. If I expand that 8-inch round up to a 12-inch round duct, The CFM is going to be the same. I'm not gaining or subtracting any air, unless I have duct leakage. We'll talk about that later. I'm not gaining or subtracting any air, but my surface area dimension became larger. And since CFM is velocity, feet per minute, times area, feet squared, that's how I get my cubic feet per minute. So if I have my duct get wider, that means my air is going to get slower. So what I could do is put a really, really, really large dimensional section in for your filter on your rooftop or your air handler or your furnace or whatever it is. But nobody wants a, 5 foot by 6 foot wide filter rack in their basement next to their furnace. That's just not realistic. So, and same thing with rooftops and air handlers. So what we do is we put the filters in a V-bank like shown in the photo here. When I put those filters in a V-bank, if you could imagine if I just stretched it out like an accordion, I have like double the amount of surface area there, which means I'm going to slow the velocity down for that brief moment when the air goes through the filter section of the air handler. So it's like I have a much larger dimension by putting it in that V-bank area for me. Residentially, we don't have space for those V-banks either. So what we do residentially is we put in pleated filters. That means in the filter, instead of having a 1-inch wide filter, I may have a 3 or 4-inch wide filter. And the filter media, I wish I should have put a picture up here. I'm dumb. I should have did that. The filter media inside that little 3 or 4-inch spot will zigzag back and forth and make pleats, which helps me get that surface area, which helps me slow the airflow down. Right. So that's the deal with that. Types of mechanical filters, there are all kinds of types out there. Most of the time we're looking at these low-end, cheap fiberglass ones that people are putting in. Typically people are using these because they don't know any different. These filters, their job in life is to keep large pieces of debris off of my heat exchanger surface areas, meaning my evaporator coil and my gas heat exchange section. And if I have electric heat, off my electric heat, off my hydronic coil, etc. If I have a lot of dirt on my heat exchangers, that will reduce their ability to transfer heat. So the original reason we put filters in equipment, in HVAC equipment, was to make sure we continue to get the heat transfer out of our coils. If I want to do a good job of cleaning the air for people, these filters aren't going to cut it. These things are basically keeping bowling balls from sitting on the coil. They're not catching anything small. They have really poor MERV ratings. People are putting them in because they are inexpensive and they don't know any reason why they would put a bigger one in, or a better one in, I should say. Panel link filters, these have fallen out of favor. They are made out of the same material as these guys, but instead of being in a cardboard cartridge, they kind of fold out. The problem with these is it's just too easy for air to bypass around them unless you do a good job installing them, which most of us don't do. So we don't use a lot of these. Some pieces of equipment you'll still see them for space constraint reasons, like some of the through the wall package units and stuff like that. But these are not very, very common anymore. Roll filters, definitely not common. I've only seen one of these, so we'll go past this quickly. It sounds like a perfect, awesome, magical idea. As the filter pressure builds up, an automatic motor turns it and scrolls a new piece of filter media into the airstream. It sounds awesome. But the problem with that is that nothing keeps that filter media tight on the left and right hand side of the drawing there, so air can bypass it rather easily. And then eventually the motor dies. That problem happens as well. I've only seen this one time. Other than that, I didn't even know it existed until I saw it that day and had to go research it. Very low MERV ratings, lots of bypass air. Nobody uses it anymore either. Bag filters are reasonably common. This is typically going to be on higher end air handling systems. The pressure drop's usually pretty high. You're not going to put this on like a residential furnace or a packaged rooftop. Plus you need a lot of depth. Each one of those bags, if you will, is like the depth of like a grocery bag. So you need some space there. You need, like 2 feet of space to install these. So typically you'll see these in higher end air handlers and typically on projects where they're trying to do a better job of filtering. They want to get up to that MERV 11, 12, 13, 14 range of catching some of those smaller particles. Cartridge filters you'll see come into play when I'm really concerned about bypass, and you'll see why in a minute. A lot of times they have aluminum frames and they're going to fit snug to each other, and then we're going to seal them to make sure they're snug. Reducing that bypass helps my ability to get to the higher MERV ratings. The filter media is going to be really dense as well, which means I'm going to typically have higher pressure drops. And then HEPA filters and ultra filters are just cartridge filters like this guy was. They're just really, really dense versions of that, and they pretty much catch everything. And they catch the air too, which is the only problem with them. You can get HEPA filters on simple systems, even like a residential system. You got to be careful with the residential one. you have to have a separate booster fan to push the air through the residential HEPA filter. Your regular furnace and fan coil fan cannot do it. The pressure drop is too great. So typically you have to do the HEPA filter in a side stream fashion, meaning you pull some of the return air off of the return duct, run it through the HEPA, and then inject it back into the return duct, which means you still have to have another filter there because not all the air is going to go through the HEPA. Some of the air is going to bypass, which is one of the reasons why I'm not a fan of using HEPA for residential applications. Commercial stuff, we do it a lot. We do a lot of hospital projects at TEC with air handlers. If you're doing stuff that's regulated by the FDA, those kind of things, IDPH, those kind of projects, you're going to have a lot of need for HEPA filters. Yes, there's a lot of pressure drop. Yes, we got to put a beefier fan in. Yes, we got to spend more electrical energy to run it. But dude, it's a hospital. I cannot afford to have infections. So I'm going to pay the electrical energy in order to make sure people don't get sick because they have their chest open in the surgery room. So we will in fact use HEPA filters in those kind of applications, but you're not going to use it like on a rooftop or like on a school or something like that, typically. There's all kinds of ways the filters can be mounted in the units. Typically on commercial systems, we're going to need more than one filter. So they'll come in panels and we'll slide them in. We want them to be fitting snug to each other. We want the door, when it closes, to have a gasketing material on it that pushes up against each of the filters. That's where you see the zigzagging on the right-hand side of that drawing. I want that gasket to push up against the filters and compress them in a little bit. If they're not compressed in, it's too easy for air to bypass around the filters. When I get into more critical applications, like hospitals and stuff like that, I'm going to need to do something to secure the filter media there, and I'm going to have to pay attention to that bypass gap because the pressure drop through the filter, in this case it's a bag filter, is really high, so air is going to want to bypass it whenever it possibly can. And in many cases, we're going to caulk between the cartridges themselves. I don't want any air gap there. So I'm going to slide these filters in. I'm going to climb in the air handler. I'm going to caulk all four sides of each cartridge and push them all together so I don't get any bypass. Yeah, it's a lot more work to do that, but you're not doing that on every application. You're not doing it on storefronts and strip malls and schools. You're doing it on critical applications. So in that case, spend the labor to do it right. And caulk these guys together. All right, I'm gonna look at the questions real quick. We do have one more question. Surprised he's the only one that's asked this. So Brian asks if there's anything we can do in a commercial building to prevent and minimize coronavirus. We're definitely going to address that. It's a challenging topic because it's so new, but we are going to address that starting now. So that's very good timing from Brian. I did not pay Brian to put that question in. All right, so let's do some residential air purifying technology, and then we'll do some commercial technology, and then we'll do some non-filter-based purifying technology. We'll try to cover it all here. So up here I got 1, 2, 3, 4, 5, 6 different filter-based air purifiers. We sell all of these. We have all of these in our inventory. I don't know why we have so many different ones. Actually, I do know why. It's just a branding thing because we like to have the filter rack brand match the furnace brand. And then we have a Honeywell one, just keep things generic a little bit. The same with the core. All 6 of these things you see on the screen all use the exact same technology from the exact same manufacturer. So we'll just talk about it once here, and it applies to all 6 of these. It's available for all of these brands. So where did my clicker not work? Oh, there we go. So how do these guys work? So first off, you got to understand that there is 2 parts to them. There's an electrical section to these, almost like an electrostatic air cleaner, almost like that. And then there's a media filter on there, a disposable cartridge, if you will. It's both of those things together. But this is the unique part. Inside the media filter of all of these different racks, there is a metallic material that runs through them, and those run to what looks like a piece of tin foil on the outside of the filter cartridge to a metal surface, and that touches the contacts of the actual cabinet, and that's what allows the filter, the disposable media filter, to be grounded, electrically grounded. So a couple things are happening here. We have a grid set up, and coming into the grid, we are charging the particles that are coming in with a negative voltage. Then we have a grounding side on the filter media. If I charge something one way, and I have another surface the other way, that'll get the positive negative attracting thing happening, and that will help the debris cling onto the actual filter itself. Then additionally, in the case of these particular filter racks, we're passing a very high voltage through there. It's about 18,000 volts. That sounds crazy, like where the hell are you getting 18,000 volts? it's extremely low amperage. So the filter itself is still being powered. The filter rack is still being powered up with 120 volt power at your residential home. But then there is a step-up transducer that's boosting it to 18,000, but it's extremely low amperage. Granted, you still don't want to open it up and stick your hand in there because that would be a bad day, but it's not a crazy high power consumption because it's low amperage, high voltage. In any case, it's passing that through there. If you are a single cell organism and 18,000 volts passes through your body, you're dead, right? Now, if I stick my hand in there and I grab onto it, I'm not going to be dead, but the skin cells on my hand, which each one of them I pretend is a little single cell organism, the skin cells on my hand that touch that surface, they're going to be dead, right? So it is going to do a pretty good job of killing it. So we're going to catch stuff with both the filter media and electronic media, and then we're basically going to electrocute it to death. It's kind of the way it works. So there is the filtering portion of this, and then there's the germicidal effect. This particular manufacturer that makes these for Carrier and Heil and Bryant and all the brands I mentioned before, this manufacturer has tested this on 3 different specific germs, on the influenza virus, tested it on the common cold, and tested it on strep bacteria. The reason they picked those 3 are those are things that most people are concerned about. It probably will kill other viruses and bacteria, but they didn't pay to do those tests because it's really expensive, like $100 grand each to have it tested on like smallpox or something weird like that. So we can't legally say it's going to kill those things. It probably will, but we can't say that. But we know for sure it's going to kill influenza, it's going to kill the common cold, and it's going to kill strep throat, which are 2 viruses and a bacteria. So it has that germicidal effect. It also has a really good MERV rating. We used to have a MERV 15 and MERV 13 model. Now there's just the MERV 15. They stopped using the lower end one. They kind of combined the features of both into one product, and it's all MERV 15 now. But if you look at that, it tells you what kind of size things it's going to be able to catch for those 3 different categories. And those numbers on top, 0.30 to 1, that's how many microns wide the particle is. So it's catching 90% of the stuff that is above 1 micron, and it's catching 85 to 95, like a range, if you will, of slightly smaller stuff, down to 0.3 microns. If we go back to our chart, oh, I thought I had the chart on here. Well, that was really small stuff. I'm not going to go back now. It'll kill us. For some reason, I must have hit the chart on accident. It's going to catch smaller stuff, physically catch it in the filter media itself. One of our other suppliers, Respicare, has a product called Ultra Clean 99, which is using an ionization type device in conjunction with a filter media as well. So we have other options in that regard. They also have a MERV 15 rating. It's a different technology, but it's trying to accomplish the same goal. And then from Respicare, which is one of our residential and commercial suppliers, they also have some other products too, like regular filters and so forth. The one I want to point out, though, is the one in the middle, that MERV 13 one. I want to point that one out because it's only 1 inch thick, which usually a MERV 13 filter is either a 3 or 4 inch filter to get all those pleats I talked about, to get the surface area, or it's a 1 inch filter that sucks. I'm not going to call any brands by name, but there's one specific manufacturer that does a really good job of selling these 1 inch filters at big box stores directly to consumers. And those 1 inch filters do a really good job of catching stuff. Unfortunately, they catch the airflow as well, and then people have their furnaces tripping on high limit and so forth. This one in the middle here, this MERV 13, is different. It is only 1 inch, but it is not very dense media, and there's no pleating. So how the hell did they get MERV 13? It actually has a power source wired to it, and inside that filter media, there's a little electronic grid, and we power it up off of 24 or 120 volts, depending on which models you buy. We power that grid up, and now I'm using the electrostatic charging in conjunction with the disposable media filter. It's meant to specifically slide into an existing 1 inch cabinet to give you the benefits of catching stuff like an electrostatic air cleaner, but also being able to throw it away because, once again, we as Americans are lazy and don't want to clean it. So that's kind of the deal with that. There's also a commercial version of that guy too. I think a question just popped up. Did I see that? Somebody asked how Train Clean Effects works. You should be ashamed of yourself of asking a Train question on here. I honestly don't know how the Train one works because we don't deal with that and I don't pay attention to them. I'm sure they make a good product. I just don't know anything about it. We'd have to research a little bit. on there. Okay, there's a whole bunch of questions. I'm going to have to come back to these in a little while because now the questions are starting to flow in. So I'm going to keep on track, keep on pace, and then we'll come back to some of these questions. Commercially, we do work with a manufacturer that does air purifying technology that is filter-based. That company is called Secure Air. This is not something we can easily retrofit because you need space to put these pieces of equipment inside your air handler. So it's got to be done kind of on a new air handler install. But if you need help with that, need information, let us know. I could do a whole hour presentation just on Secure Air and how all their technologies work. But the simplest way to think about it for the moment is it's basically the same as these guys, but it's a commercial version. I probably can't say that because it legally is not exactly the same, but it's kind of doing the same kind of things. And we'll just leave it at that for now. And then our folks at Respicare, our friends over there, also make those same kind of like 1-inch type high efficiency filters that we were talking about residentially. They make commercial size ones as well in 1 and 2-inch versions. All right, let's talk about UV lights. Keep on path here. I'm going to go express fast on here so we can get this whole entire thing done by like 12:15 so I can eat my lunch. And it is about me, so. All right, so we're going to use UV light to kill stuff. UV light is also coming from the sun, right? There's different bands, different wavelengths of light. Hopefully you know that light travels in a wave form. There's different wavelengths measured in nanometers. Those ranges of wavelengths determine whether it's UVA, UVB, or UVC. We're going to focus on UVC, which is ultraviolet light for germicidal purposes. That's the kind of products that we, the industry, are going to put into air handling systems. The sun's working the same way, though. Those sun rays are shining down onto stuff, and this UV light can kill stuff. So, for example, when you walk outside with no shirt on or with no sleeves on, and the sun shines on your skin, the sun starts killing the skin cells on the outside surface of your skin, which is why you get a suntan or a sunburn. That is your skin dying. Sure, it looks great when you have a nice suntan, but it really is an indicator of dead skin that was killed by the UV light of the sun. It breaks it down. It breaks down the DNA of it. This is not a new thing in any way. This is really, really old stuff. They've been using UV lights for air purification purposes since the 1950s. Old technology. But it gets misapplied all the time. Like all the time, meaning literally all of you on this webinar probably are doing it wrong. What do I mean by that? I shouldn't pick on everybody that's attending the webinar. What do I mean by that? So in order for UV light to work, I have to have either a really, really, really high energy source, or I have to have a really, really, really long exposure time, or some combination of those two things. So when I walk outside with my sleeves rolled up and the sun burns my arm, that's because the sun is a massive energy source. But I still need a lot of time. Like for me, it takes me like 2 hours for me to get a sunburn. Other people, 10 minutes, 15 minutes. But either way, 15 minutes is kind of a long time. So in an air handling system, if I have air moving across a UV bulb, how fast is that air moving? 400, 500, 600 feet per minute? It's going to be in shining range of the light bulb for a couple seconds, and then it's gone. So unless you're a germ that runs directly into the light bulb like a bug zapper, unless that happens to you, you're going to waste scot-free. If you go past the light bulb a couple inches away, you're not getting killed. A UV light cannot kill germs in moving air. But Ryan, we call it an IAQ product, indoor air quality. Yeah, we do, because it does help keep the air clean, because it helps kill stuff on stationary objects that would later become airborne, specifically evaporator coils and condensate drain pans. Those things can get gross. Things can grow on them. If I put a UV light on there, like the picture on the left shows, above or below my coil in this case, and this is a lot of light bulbs. It's like 6 light bulbs, and you probably could have did it with 2, but nonetheless, those lights can shine on that coil surface area for hours at a time. So I don't need a large energy source. I just need a small energy source. 10, 20, 30 watts, I'm good. Because I have a lot of exposure time to work with it. So a UV light does a really good job of killing germs on a surface like a coil or a condensate pan. It does not do a good job at killing germs in the air. Mounting a UV light in the return duct is completely worthless. There's nothing that's going to happen there. The coil is where the action is at because the coil has the moisture, hence it's going to be the one that's going to be most likely to grow mold or bacteria. All right, just to give you an example, that blue circle in there is my UV bulb. If I say that I have full power at 1 inch away from the bulb, if I get 2 inches away, I lose 75% of its killing power. If I get 8 inches away, I lose 98% of the power. So things flying by through the airstream, they're not getting affected by this at all. Only for stationary objects. You can mount these above and below your coils. If it's a air handler and it's horizontal airflow, like on a rooftop or something like that, you can mount it before and after. If you're only going to be able to purchase one UV light for your system, put it on the side of the coil that has the drain pan. That way it can shine on the coil and shine on the drain pan. If you can afford 2 bulbs, put it on both sides of the coil, and it'll keep it clean. On the left, we're showing a dirty coil without a bulb. On the right, a coil with a bulb. Theoretically, if you put a UV light on a dirty coil, it'll kill the stuff that's on the coil. As that coil heats up and cools down over the months, it'll expand and contract. So when that stuff is dead, it'll no longer flex very well with the movement of the coil. So it'll crack it and the debris will fall off. You could put the UV light on a dirty coil, wait 6 months for it to be clean, and then tell your customer you're awesome. One, your customer doesn't want to wait 6 months for the coil to be clean. That's disgusting. Two, that debris is going to fall into the drain pan and clog it up. So whenever you put a UV light on an existing system, you need to clean the evaporator coil first, and then put the UV light on there to keep it clean so the bad thing doesn't grow again. Here's an example on a commercial system. It works exactly the same as a residential system. We just need more bulbs to get more surface area coverage, depending on how big my coil happens to be. Fun fact, it doesn't take much debris on a coil. 0.002 inches of debris on a cooling coil will reduce the airflow by 9%, which is going to affect my heat transferability as well as my airflow, so that's going to affect my energy. So keeping your evaporator coil clean, just like keeping your filter clean, will help improve the electrical efficiency of your system. You bought a MERV 16 system, or excuse me, a 16 SEER system residentially. You want it to actually act like 16 SEER, keep the pieces clean. A little side benefit. Yeah, we're killing germs, but we're also keeping the coil clean for energy reasons. All right, there are some other technologies that use bulbs. One such technology is photocatalytic oxidation, PCO technology. The photo means there's a light involved. So I got a light bulb in here. Although this light bulb, his job in life is not to clean coils. He will do that incidentally, but that is not his primary job. His primary job is to be a catalyst to cause a chemical reaction. In this case, it's going to cause a chemical reaction to create an oxidizer. So what the heck does that mean? So first off, when I put one of these PCO devices in, if I put the PCO device, like this guy here, this is a residential version, there's also commercial versions, I put him in right above my evaporator coil in that case, he's going to shine on the evaporator coil, which is going to in fact keep my coil clean, helps keep the mold and bacteria from growing, a little bit of energy benefit, everything we just talked about with a regular UV light. The other side of the light bulb though is going to shine onto the actual media that's around it. In this particular example, the one I'm showing here, it's going to shine it on carbon cartridges. Carbon is really good at absorbing odors, and this light gets used to regenerate the carbon, so I don't ever have to replace these little honeycomb cartridges. I can use them over and over and over again. They just stay in there. They get refreshed, if you will, by the UV light as the cartridges continue to absorb odors, and that's a nice little benefit. Then the PCO part comes in as like kind of the third mechanism for this discussion here. The PCO part is where I'm going to get the germicidal effect. So it's got the UV bulb shining on the coil, great. It's got the UV bulb shining on the carbon cartridges, absorbing odors, great. And now it's got the UV bulb shining on the metal material that's interlaced onto those cartridges. In this particular case, the one we're looking at is titanium dioxide, is the metal that's on there. When I shine the light on titanium dioxide, it creates hydroxyl radicals. And if you flash back to like high school chemistry, hydroxyl, hydrogen and oxygen, okay, we can comprehend that. Radical means it's not a very stable compound. And most things in the universe are trying to get to a stable state. I mean, they don't really try. They don't have like wishes and goals and feelings, but they are trying to get to a state of equilibrium, state of normalness, right? So things that are in a high pressure area try to go to a low pressure area, high humidity to low humidity. If I have high and low temperature, they try to mix. Everything's kind of trying to do that in the universe, at least in my mind. So in this case, if I have a radical, I have an unstable compound. He doesn't want to be that way. He wants to be a stable compound. So as he bumps into and runs into other things, it is going to break him apart, and they're going to reform into more stable things. And that's where some of this benefit's going to come in, breaking down VOCs and things like that. Some of these manufacturers of PCO devices test their stuff, just like we talked about Carrier testing their stuff on flu and cold and all that. These guys do the same kind of thing. A lot of manufacturers of these devices will just test one bacteria, one virus, one mold, because the tests are so expensive and only certain laboratories have access to these viruses and stuff like that. they can only really afford to test it on 1 or 2 things. So they pick 1 or 2, test it on there, and hope it does a good job with all the other ones. It's kind of like the mentality. We happen to use a product called from Respiracare called Oxy-4. So Oxy-4 is a PCO device, and it has an ionic benefit, which we'll explain here in a minute as well. It's kind of a combo deal. It's an all-in-one type thing on there. So this guy is going to do a good job at attacking mold, attacking microbials like viruses and bacteria, absorbing odors, and breaking down VOCs. It's kind of like everything in one. So he's going to kill, he's going to oxidize, he's going to sterilize, he's going to neutralize, he's going to use hydroxyls, like I just explained, to do that. He's going to use hydroperoxides to do that, which is like brown bottle hydrogen peroxide, mom poured it on a cut, you screamed like a baby. It's that kind of stuff, but it's in the air, which is cool because it makes it in your duct system, and the airflow of your duct system takes the hydroperoxides out into the space to actively attack stuff. So those air purifiers we were talking about with the filter racks, those are cool and they kill stuff, but they wait for the germ to come to them. Something like this goes out proactively into the space and lands on countertops and doorknobs and things like that and starts killing stuff. Does that mean you don't have to clean your countertop anymore? No, dude, you still got to clean your house or your building or your school or your tables, whatever they are, but this will help the process. So if people are in the space coughing and there's another person on the other side of the room that could be the recipient of that, there's a possibility that this guy could attack those germs before they get to the second person. That's kind of the cool story with these guys. And there's also going to be a commercial, not going to be, there is a commercial version of this as well. It's just physically bigger. So inside either the residential or commercial version, there are bulbs that go down the middle to cause those chemical reactions, and they shine on those white plates, those honeycomb type cartridges, to get that titanium dioxide to react and cause these reactions for us. The big difference between the residential and commercial one, other than the length of it and hence the output ability of it, is that the residential one also has a screen on it, and that screen will tell the homeowner when it's time to change the bulb inside there, and it'll tell them who their contractor is on the screen so they know where to get another bulb from. The commercial one doesn't have that for 2 reasons. One, it usually goes in a rooftop unit, and hence putting a screen in there makes it a little bit harder with the weather situation. But 2, there's nobody's head up and looking in the cabinet of the rooftop unit to even see the screen anyway, so why even bother paying for an LCD screen? And then there are also indoor mounted versions of these that are magnetic, like the top one on the right, both residential and commercial. So if you don't want to drill it through a duct and have this blue box sticking out of the duct, you can put it inside the unit and have it attached to the inside wall via magnets that are built into it. So that's good, really good for air handlers and rooftops as well. The benefit of these things, of any of these air purification things, people that are sharing germs and odor type applications, right? So schools and daycares are no-brainers. Like there's 30 kids in a room, they're all sick, or 2 of them are sick, and then they all get sick. If I can do something to neutralize that and reduce the amount of sick days kids are using, same with daycares. Every time a kid doesn't go to daycare because he's sick, a parent also has to stay home from work, which then screws up the whole family schedule. Any place where people have compromised immune systems, so obviously daycares, small kids, nursing homes, elderly sick people to begin with, those kind of places can really benefit from this germ reduction type stuff. There is another way to do this, right? So we have the filter-based ones we were talking about that create these oxidizers. We have the light bulb-based ones that create various kinds of oxidizers. Then we have bipolar ionization. The reason to have bipolar ionizers are because some people don't want the bulbs. For whatever weird reason, they don't like the fact that they have to change bulbs, even though that's probably a more effective way to get the job done. But there are other ways to do it. Bipolar ionization is one of those ways. Bipolar means there's two poles. Essentially, one of those needles in the picture on the bottom right is charging air positive. The other one is charging some of the stuff in the air negative. And then later on, these 2 things that are charged positive, negative are going to slam into each other because positive and negative attract each other. So they're going to slam into each other. When those guys do that, those charged particles, they're going to create these hydrogen-oxygen ions that are called plasma or bipolar ionization. This is good for breaking stuff down. It's really good at attacking various chemicals to break them down. In some cases, the chemicals can be hazardous, like ammonia or something like that. I pick ammonia because that's the one I happen to have a little animation of. So ammonia is 3 parts hydrogen and 1 part nitrogen. Hydrogen by itself is not bad. Nitrogen by itself is not bad. But when you put it in that combination, it's ammonia, and it's very difficult to breathe, obviously. So it goes through one of these plasma fields, it breaks that thing apart. And now I have 3 hydrogens floating around and 1 nitrogen floating around. Well, what the hell are these guys going to do when they're floating around? They want to be stable. Like I said before, they're not going to just keep floating around. They could recombine into ammonia, but ammonia is not super stable. It's more likely a couple of hydrogens might jump onto an oxygen atom, and now I got H2O, water vapor essentially, and the nitrogens may buddy up, and now I got N2, which is the same nitrogen that I find in the Earth's atmosphere. It's like 80% of the air you breathe is nitrogen. They also have the ability to form these ion clusters, which basically can surround stuff. What is the stuff it can surround? Well, in our concern here is they have these ion clusters that are creating hydroxyls. They can surround a virus and essentially, for the most part, suffocate the virus. These viruses need to have hydrogen in order to survive. And when they're all surrounded by these hydroxyls, they can't get new hydrogen and they basically suffocate to death. That's the way they kind of attack some of these living organisms like a virus. And of course, the manufacturers of these technologies do testing as well to show you that they can test certain kinds of bacteria or kill certain kinds of bacteria and viruses and stuff like that, and the kill rates. So every manufacturer of this stuff can give you a data sheet showing you their kill rates. The bipolar ionizer we use now is also from Respicare because we used to have a manufacturer for bipolar ionization. We had another one for PCO. We had another one that created hydroperoxide ions. We had all these manufacturers. We since, maybe 3-4 years ago, standardized on Respicare because they make all of those things. So we can have one vendor to deal with, and we're lazy, so we want one vendor. So they make all these things for us. Plus, they have some of those filtered products I was talking about before. So they make all kinds of stuff. We can't dive into all of it now. They make UV lights. They make air purifier filters. They make duct-mounted purifiers. They make mold-reducing duct-mounted things. They make those little skinny filters. They make that Oxy 4 thing I was talking about. They make PCO devices that are a simplified version of the Oxy 4. They have all of that stuff for us. And then, of course, in order for us to believe in it and show people that it's going to work, they have all the test data that we need. So for various products that they have all the test data. And I'll just throw some of them up here just for argument's sake. MRSA, staph, those are things that hospitals typically get concerned with. Strep throat, various kinds of bacteria that I can't even pronounce it. That Stachybotrys one, which is one that everybody's kind of scared of. E. coli. It can break down different kinds of chemicals like formaldehyde and stuff like that, ethanol. It can break all that kind of stuff down. It actually can help out with some of the particulate matter as well because of that positive-negative thing. If some of the particulates get charged positive, some get charged negative, they attach to each other. Now my little dust bunny is a bigger dust bunny, which means he's more likely to get caught into my filter, so it makes my filter efficiency better. I don't get a new MERV rating because the filters are tested independent of these air purifying companies' duct-mounted things, but it does kind of make it seem like it's a better MERV rating. For you guys that are in the need, there's a couple last things on here. There's a couple more webinars coming up on this subject I'm going to tell you about in classes. And then there's also this tool I wanted to point out. We don't sell this tool, but we can help you get the tool if you need it. I know the Carrier and Bryant guys got some kind of discount they get on it, but it's available to other people as well. It's called Air Device. We started using it a long time ago, so long ago that it hooked up to a dial-up modem line, which is crazy. Now it goes through a cellular network. You put this device in somebody's home or even a small business, and it will then 30 minutes later email you a report telling you what it is. This is a report from my house, so it's telling me my particulate count was low, which this is before I had like a MERV 10 filter at this time. Now I have a MERV 13. I had a MERV 10 filter, and I did have a duct purifier, but not one that did particle grouping like I talked about. Now I have a MERV 13, and I have one that does particle grouping. But in any case, this is my particle count, and this is what it'll show you at anybody else's house, tell you your VOC account and where it is. If there's a problem, what typically are the causes of that problem? What might you do to reduce the problem? It also gives temperature readings, humidity readings, adds those into the discussion, and then it'll even give you a report suggesting various types of solutions and products that you might be able to use. What are the things that come up? Ventilation air is huge for helping out with indoor air quality. Yeah, it's really good to have good filters. Yeah, it's really good to have air purifiers that kill germs and stuff like that. But ventilation air is a big deal because it helps dilute things down. Indoor air, generally speaking, is worse than the outdoor air. Unless you live next to some kind of coal-fired power plant, the indoor air is probably better. So for residential and commercial systems, required by code for everywhere in the states that are probably listening to this, you need to have mechanical ventilation, fresh air being taken into the building. you can just have that coming in, or in some cases you may want and or need to run it through an ERV or HRV. And then in the case of commercial systems, you may want to do CO2-based demand ventilation, which helps you bring in more ventilation air when a lot of people are there and bring in less ventilation when less people are there. So you don't have to spend energy to heat and cool air when somebody's there. Duct smoke detectors. This is beneficial as well. Commercially, it's required for 2000 CFM systems and up that you have a duct smoke detector that shuts down the air handler if the smoke is present in the duct system. Obviously, we don't want to continue moving air in a building to feed oxygen to flames, and we also don't want to spread smoke from one room to the next room to the return duct system, thereby making more rooms have problems. It's not required residentially, but those same $100 and some detectors can be used on residential systems just like they can be used on commercial systems. I just installed one of these at my house recently, hoping it never goes off, but nonetheless, I put one in. There are other things that you can do. If you have specific pollutants you are concerned with, you can buy sensors to sense those specific things. Like, for example, most of us have carbon monoxide sensors at your house. At a house, it is recommended you put one on every floor of the home, and you make sure that you put one in wherever near the mechanical equipment is going to be, like the furnace, for example, if the mechanical equipment is gas-fired. If you have nothing gas-fired in the home at all, no stove, no dryer, no fireplace, no furnace, no water heater, everything's electric, you don't need a carbon monoxide sensor. But as soon as you have one gas-fired thing in your house, you probably should put this guy in. You can also use these commercially if you like. It's not as common to have it there because, like, residentially, the fear is like you get carbon monoxide poisoning while you're sleeping and you don't know what happens and then you die. Commercially, you would probably start feeling sick. Even though you can't smell carbon monoxide, you'd start feeling sick and maybe you'd leave the building then. But no reason you can't put a carbon monoxide detector in a commercial building. And then if you've got swimming pools or parking garages or things like that, there are certain sensors we might put in. Get a chiller room, we'll put a refrigerant leak detection system in. And all of those things can each be a 1-hour webinar in and of themselves. But I just want to throw them out there. Actually, we have 1-hour webinars on them on our website already for all of these things. We have them for ERVs, we have them for duct smoke detectors, we have them for carbon monoxide, we have all that stuff if you want to watch older webinars on it. Dehumidification and humidification can also have an effect on your air quality. When things are really dry or things are really humid, bad stuff is more likely to happen. We'd like to keep things between 30 and 60% humidity if we can. Sometimes 30 is a little high because it causes the windows to sweat, so you got to tolerate a little bit lower number, like maybe 20. The 60 end is pretty much a hard number. There's two different ASHRAE standards. I forget which one cites which, but ASHRAE 62 is the indoor air quality standard. ASHRAE 55 is the human thermal comfort standard, and one of them specifies a maximum of 60, the other one a maximum of 65%. So I always tell people just do the 60, then you're covered for both. But you do not want that space to be above 60% humidity or bad stuff is going to start happening. It takes like 2 weeks to grow mold at 70%. It takes like 3 days to grow it at 80%. So you don't want that to happen. Correctly sized systems, more surface area on the evaporator coil, lower airflow CFMs, all those things will help you with the dehumidification discussion. And of course, putting in dehumidification sensors would also help with that. Residentially, you put in multi-stage equipment, put in a 5-stage condensing unit, it's going to really help out with dehumidification. Commercially, same kind of thing, get more stages, put in a variable speed fan. If you have like a fitness center or something like that, look at Carrier has a product called Humidizer. Take a look at that. That guy will help do dehumidification in some pretty unique ways. Once again, it's a whole other 1-hour webinar. And then lastly, duct leakage comes into play. If I have leaky return ducts and those return ducts are running through crawl spaces and attics and whatever, it is sucking in whatever is in that air. It could be raccoon poop in your attic. It could be mold and mildew in your crawl space, whatever that stuff is. It gets sucked in, and then your duct system distributes it to all your rooms so your whole building can breathe that. Same thing happens commercially. We have plenty of duct systems that are going through some pretty nasty spaces, especially in older buildings. We don't want it to suck all that crap in. So sealing up the ducts is critical from both an energy standpoint, from a comfort standpoint, getting the right amount of air to the right rooms, and then for today's discussion, an indoor air quality standpoint. You can seal the ductwork manually with mastic, with tape. You can weld it, you can gasket it, all those kinds of things. But when it's existing ductwork, the easiest solution is AeroSeal. Yes, we do sell AeroSeal sealing for commercial systems, hence why I'm talking about it now. So yeah, it's a little shameless plug, but I don't really care. We've done some pretty big jobs with this. It's a pretty cool technology. So what ends up happening is you isolate a section of the ductwork. So you block off all the diffusers with these foam blocks. and then you isolate off the section so the evaporator coil and everything is not accessible either. Then I connect this aerosol system to that duct. It's basically a fan box. It's a fan box that has an injection nozzle in it. And that nozzle is injecting liquid glue in an aerosol form, so it's misting the glue into the air, if you will. Then that glue travels down the duct system, and as air leaks out the cracks, the glue balls from the air cling on to the edge of the crack, and they start coagulating on that crack until it seals it shut. And then the next set of glue coming down the duct skips that hole because that hole is already sealed and goes to the next hole. And you seal the ductwork up that way. If you need more information on that, once again, it's a whole nother 1 hour webinar. And in fact, in 2 weeks, I think it is. March 25th. People's Gas is going to, and North Shore Gas. I shouldn't cut them out of the discussion. People's Gas and North Shore Gas are doing a joint webinar for commercial aeroseal systems. If you need the link to that, I'm going to paste that link into the notes section on this webinar we're on right now, and you can click on that. I'll do that in a couple minutes here, or you can send me a note and I'll send it to you later. Very last thing for you guys on the residential side, right? So that aerosol thing was for the guys on the commercial side. This is for the guys on the residential side. This 1 hour discussion that we just did, or 1 hour and 13-minute discussion, is a reduced version of a 3.5, 4 hour class that we normally do all the time. The next version of that class is coming up in a couple weeks on March 27th. When I did a screenshot of it yesterday, there was still 44 seats open out of a room of 60, I think it is. So that means 16 people are signed up. I expect probably by the end of the day today, it's probably going to be filled. We just launched the registration 2 days ago for it, so it'll probably fill up pretty quickly because IAQ is on everybody's mind at the moment. I am going to put this link in the note thing as well. So let me do those two link things so you guys can click on them if you want to, and then I'm going to go back and read the questions here. Give me 1 second just to cut over and grab these links. So this link that I'm going to put in now is for the People's Gas one. Paste that in here and hit enter. You should be able to click on that one if you want to go to that registration page like I have on the screen. And this one here should get you guys on the res side over to the IAQ class if you want. And by the way, that class does qualify for NATE hours if you should need NATE hour type stuff. And let's go through and look at some of these other questions here. Give me 1 second to expand this bigger. Maybe that was a better ninja. I could do it. Okay. Expand it bigger. Okay. Okay, lots of questions obviously about coronavirus on here. There's no manufacturer of any IAQ product that has tested their product to guarantee that it's going to be able to kill coronavirus. It's a relatively new thing. These testing processes take at best months and months and months and hundreds of thousands of dollars. So nobody has any data showing for sure that they can kill the coronavirus. They will be able to provide you data like I did today showing that you can kill lots of viruses and various versions of viruses. So it might kill the coronavirus. It probably will kill the coronavirus, but you won't be able to guarantee that from any manufacturer right now. 2, 3, 4, 6 months from now, someone might have a different answer. But getting access to this virus to have it tested is not really easy to do right now. Ahmed asks, can you share your thoughts on how to place proper filters for furnaces that are sitting directly over a return air boot? Return grill is directly connected to the side of the boot. Furnaces that are sitting directly over a return air boot. I don't know exactly what that means. You'll probably have to send me a picture of it because I'm not smart enough to figure out what that means on there. Apologize for that one. What pressure drop do these filters have? How strong of a blower do you need to not overheat? I don't know what filters were on the screen at the time that that question was asked, but you want to get a filter that does not have exceedingly high pressure drop. Any manufacturer of a good filter will publish the pressure drop along with the MERV rating. If they don't give you those two things, probably not a good filter, or probably not a good MERV rating, or probably not a good filter pressure drop. If they're proud of it, they'll put both of them in their documentation literature. Not in the sales glossies, because that doesn't make sense, but like in the product data or the product spec sheets, you'll have it on there. So like, for example, I'm assuming he was talking about some of those residential air purifiers, those 6 of them that I had up there, Bryant, Carrier, Honeywell, Heil, all that stuff. Those guys have a pretty low pressure drop. It ranges from 0.1 something to like 0.3 when it's dirty. They load differently than other filters. Most filters load on the face. These ones uniquely load from the backside forward, so they can tend to take more debris in, and they don't need to be changed as often. So I changed mine at my house based on pressure drop because I'm a dork, and I had that kind of filter media, and I've had it for 3 years, and I changed mine at 13 months, then 9 months, then 11 months. That's how long it took for the pressure to build up for me to have to change the filter. It varies from year to year depending on how many hours it runs and all that kind of stuff based on how hot and cold it was outside that time of year. But Doug asks, what about ozone byproduct? I'm not sure exactly which technology Doug was referring to at that moment. Probably one of the bulb-based technologies is my guess is what he was asking about, because that question comes up frequently. Ozone, if you didn't know, is O3, so 3 parts oxygen all attached together. Same smell after like an April air rain, right? That kind of thing. And I say April air, I don't mean April air the manufacturer, which is also fine. I mean April air outside during April. I probably should have said that a million better ways. So a lot of these electronic things with the bulbs have a slight ozone byproduct. What do I mean by slight? I mean, if you have a plasma TV at your house, I realize everybody's got LCD now, but when you had a plasma TV, it had more ozone byproduct than one of these things do. There are products that are ozone generators that are used for indoor air quality control. They purposely generate ozone because ozone's really good at attacking all kinds of stuff. Typically, you only see ozone generators in remediation applications. Your basement floods, they rip all the drywall out, they bring in a couple portable ozone generators, crank them up for like a week or two, and let them just start killing stuff in the basement. Right? It's only for a couple weeks, so it doesn't have any long-term effects on you. And then you take them back out. I would not put an ozone generator in my house permanently. Now, there are these products that have a slight ozone byproduct. I'm fine with that. I've had ozone byproduct air purifiers in my house for 1, 2, 3, 4, 5, 6, 7, 8, 9, going on my 10th year now. All my kids are healthy. No one's died. No one's had any weird things happen. But it's a really, really small amount of ozone. Each manufacturer can probably give you the amount of ozone it is, but it's almost an immeasurable amount. But nonetheless, Doug, there is some there. John asks, can a Respicare Oxy 4 be installed on a return duct? Yes, it could be installed on a return duct, as well as Respicare's PCO devices and other manufacturers as well. However, that would not be the ideal place for it for 2 reasons. One, if I put it near the evaporator coil and it has the ability to shine a little bit on the evaporator coil, I get a slight benefit of that UV light type thing on the coil. But 2, more importantly, if I put it on the return duct, once I create these oxidizers and these hydroxyl radicals and they go out into the system, if it's on the return duct, those things go to the filter first, and then they spend all of their usage on killing stuff in the filter, and hence they're not available to kill stuff in your space. Now, granted, having everything on your filter be killed sounds great, but I'd rather have it kill stuff in my building first instead of worrying about my filter. So putting it on the supply side of the system is much preferred. But if you absolutely couldn't fit it on the supply side for some reason, yeah, you could put it on the return duct and still get some of the benefits. Paul asks, what is the average life of those bulbs? I don't know which specific product we were talking about at that specific moment that you wrote the question. I guess I should have been going through the questions more timely. But if it's a UV light, most UV light bulb manufacturers make 1-year bulb and 2-year bulbs. And they know exactly how long the bulb is going to last, like to the month. So a 1-year bulb pretty much dies on month 13. And even if it didn't die, it doesn't have a lot of output available to it. You can buy different versions of those bulbs on there. The PCO and those type of devices, same kind of thing. Typically, they're a 1-year bulb. I have seen some manufacturers that have longer than 1 year, but 1 year is pretty much the norm. The Oxy 4 has a 1-year bulb as well. So every year you would change the bulb. On the Oxy 4, it has the screen will alert you and make a beeping noise and alert you to who your contractor is that installed it and how you can order more bulbs from them or order a replacement bulb for them. But 1 year is the most common. You can find sometimes it has a 2-year bulb on it. John asks, and it says John logged off, but he asks, can you overdo it? Say both a UV light and bipolar together. No, but in that particular example, a UV and a bipolar would work fine together. The UV's job is to shine on the coil. The bipolar's job is to clean stuff in the air. Now, if you're doing both of those things anyway, you might as well just get a PCO style device or an Oxy 4 device because it's already doing the UV coil cleaning thing if you place it near the coil, and it's already doing the germicidal thing like the bipolar does. So it would not make a lot of sense to me to do a UV and a bipolar. The only reason to do the bipolar ionization is because you don't want to buy bulbs because you don't want to change bulbs. It's the only reason to do it. So if you're going to combine it with a UV light, you're already changing bulbs, you might as well just do an Oxy 4. Doug says larger filter, lower feet per minute, lower static, better air filtration. Absolutely. Doug, you're a genius. If everybody thought the way you thought, life would be great. Yes. Just because the opening on the side of your furnace or the return duct on your air handler or whatever is a certain dimension doesn't mean that's the size of the dimension you want the filter to be. If you can get a bigger filter rack and you have the space to do that a little bit, way better. You're absolutely right, Doug. For all the reasons you said, lower velocity, lower static, better filtration. It's a winner. Doug's got a lot of questions or statements. In this case, he said he has an Oxy 4 at his own house, and it produces a sweet odor smell. I've not heard anybody say that. That sounds awesome. Maybe it smells like a confectionery in Doug's house. And I've not heard that. I have heard some people talk about some smells. Specifically, we get occasional objections, both on Oxy 4 as well as on PCO devices, that there's like how do you want to describe it? Like a clinical metallic type smell. The best way I can describe it is you go to the dentist's office and the dentist assistant sits in the chair, puts the bib on and all that good stuff, and then brings out the tools. There's like 30 tools in this bag. They only use like 2 of the tools, not all 30, so I don't know why there's so many. But in any case, they open that bag and you get this like whiff of this metallic smell for a couple seconds. It's that smell. That's the smell people have experienced with some of these devices installed in their buildings or in their homes. I don't find that objectionable. I find that to be the smell of cleanliness, so I'm good with that. But some people don't. Some people will notice it, some people won't. Typically, if they notice it, it means they have too high of an output. So for some manufacturers, you would take their product out. Say you take their 9-inch bulb out and you put their 5-inch bulb in on their PCO device or on their hydrogen peroxide generator device. In the case of Respicare, inside the Oxy 4, there are these little metal shields. There's 2 bulbs in there, and there's these little metal shields that block off part of the bulbs. You can rotate them to get more output. You can take them off to get even more, or you can rotate them the other way to block off some of the output. So you have some output control. And by you, I don't mean the homeowner, I mean the installer does. So if someone complained that they were getting too much of a metallic type clinical smell, you could open up that Oxy 4 in a matter of 3 minutes, open it up, rotate the metal clips to block off some of the light bulb output. In my case, I ended up, honestly, what happened at first when I got the first one, I didn't think it was working, and I was complaining to the people at Respicare that their product wasn't good and all this stuff, and they were obviously mad at me and thought I was an idiot, and they kept sending me new ones saying, try this one, maybe you got a defective one or something weird. And then finally, the one time the lady said to me, well, you did rotate the clip to get more output, right? And I was like, what? What rotate what clip? What are you talking about? I did not only rotate them, I took the clips off, which quadrupled my output. It's been great since then. So people that, I have 4 kids and we're messy people and we have plenty of reasons for that product to have things to attack. But if I was living by myself or it was just me and my wife or I had a studio apartment, I wouldn't want that much output and I want to rotate the clips closed instead of open. So you got some flexibility there. Robert asks, what would the best product we talked about today be to offer to a customer? Obviously, very loaded question. Depends on the customer, what they need. If they are residential or commercial, if it's like a hospital, not a hospital. But I'm going to make the assumption for the moment that Robert is talking about a residential consumer because 3/4 of the people on this webinar were doing residential work. I would probably offer the Oxy 4, honestly, because it's easy to install. Like I said, I have that ducted air purifier. I have a Carrier one, but the Heil and Bryant, they're all the same physical housing. And it's nice and everything, but you don't just go pop it in, right? I have to do a little bit of ductwork movement to do that. It's really good to put it in on a new furnace install, but just like randomly on someone's existing home, if you're running a residential service call and they say, hey, what can I do to help kill some viruses around here? The Oxy 4 would make sense because you can put that in real easy. You're cutting a hole in the duct and you slide it in, you plug it into the outlet next to the humidifier plug. It's super easy to do. We got like an 8-minute video on our YouTube channel to show you how to do that if you're interested. Karen asked for the price range of an Oxy 4, residential and commercial. I don't know how much anything costs. I have ideas in my head, but I'm going to have you talk to your TEC sales rep to get the exact price because I don't know if you're a contractor. I don't know if you're a homeowner that needs to pay for labor to also install the thing. I don't know how any of that works. So I'm going to ignore that. Some of the people that work in my office are now typing in the price for me so I could see it, which helps, but I still don't know if this person that's asking needs it to be installed, not installed, commercial, residential, size, any of that stuff. So I'm going to leave that cost for a separate discussion by somebody that cares about money, which I do not. I mean, I care, but that's not my thing. All right, I am 26 minutes over the time I thought it was going to take, and I cut out 180 slides. So sorry about that. If anybody has any last lingering questions, you got 1 minute to type them in, and then I'm going to close it down. If you look in the chat box, you'll see those two links. The first one is for the March 25th People's Gas webinar on aero seal duct sealing. And the second one is for the March 27th half-day residential indoor air quality class, which is fantastic for both comfort advisors as well as service techs, because not only will we talk about how these things work, kind of like we did today, we'll also talk about what you need to do to install them. So it works out pretty good in that regard. Not seeing any more questions. So with that, I am going to close the question box. If you have other questions, you have to just hit me or one of my coworkers up and we will get you the answers. I'm sure you guys have tons of other questions too. Thank you guys for your time and we appreciate it.